Have you ever thought about that small, colorful pencil in your hand? It's not just a drawing tool. It actually contains a tiny chemistry lab, an engineering marvel, and nature itself. So, how are these colorful magicians born? How are they shaped? Today, we're opening the usually closed factory doors and taking the first step in the production process together. Are you ready? It all starts with tiny colored powders called pigments. These are the true source of color. Natural pigments include iron oxide from the earth, which produces red, yellow, and brown tones. Ultramarine blue from lapis lazuli, or plant-based root dyes, which yield paler, pastel tones. Synthetic pigments, on the other hand, are produced in laboratories. A substance called phthalocyanine provides striking blues and greens, while bright red and yellow tones are also obtained this way. These pigments are light-fast and incredibly vivid. Let's move on to the binding system that holds the pigments together and forms the paste that gives the pencil its shape. Waxes, such as paraffin or carnauba, determine the pencil's softness, ease of application, and resistance to breakage. Carnauba wax is harder and more expensive, so it is used in premium pencils. Clay or talc as fillers adjust the texture and opacity of the paste. Oils, such as canola oil, soften the paste and provide fluidity. These oils give the pencil that creamy feel. The wooden casing surrounding the pencil is usually made of cedar. Why? It is soft, easy to cut, provides a smooth surface, and has a pleasant scent. All these raw materials are poured into huge twin-screw mixers or extruders. This machine works like a powerful pastry mixer. Inside, heating chambers melt the beeswax. The rotating screws turn the melted beeswax, oil clay, and color pigments into a homogeneous paste. Temperature and time control are crucial at this stage. Otherwise, the paste can become too hard or too soft. The resulting paste resembles a hot, dense ball of color. The soul of the pencil has now taken physical form. The hot paste balls are fed into a second extrusion machine. This machine pushes the paste through a mold with small holes of the desired pencil tip diameter. In front of the machine, thin, colored strips begin to appear, continuously extending, much like pasta production. These continuous strips are cut into specific lengths, usually 15 to 20 centimeters, using a precise laser cutter. We can now call them pencil cores. They are still naked and fragile, as they do not yet have their protective casings. The cut pencil cores are placed on large shelves and taken to drying rooms. The goal here is to ensure that the oil in the binder evaporates evenly and the beeswax solidifies again. They spend hours, sometimes days, under controlled temperature, humidity, and airflow. This process is critical. If they dry too quickly, cracks form inside and they become brittle. If they dry too slowly, they remain soft and weak. This is where the secret to the pencil's durability lies. Once the cores are dry and hard, it's time for them to go into their protective homes. The groover machine cuts grooves into wooden slats that are just the right size for the pencil cores to fit into. The cores are placed into these grooves one by one. A second grooved wooden strip is glued on top to close it, forming a giant pencil sandwich. This combined block passes through the pencil shaping machine, acquiring its perfect round hexagonal or triangular cross-section. Hexagonal is preferred because it doesn't roll on the table. The products, now taking on the appearance of pencils, receive their final touches. They are lightly sanded for a smooth surface. They are painted in the brand's characteristic color, such as Faber-Castell's green, and coated with a glossy finish. High-speed printing machines stamp the logo, color name or number, and hardness rating onto the pencil. A small metal ring and an eraser are attached to one end of the pencil, while the other end is tapered to make it ready for use. The pencils are sorted by color using optical sensors. Automatic packaging machines place them in their boxes. The boxes are sealed and wrapped in stretch film, ready to be shipped to artists, students, and dreamers around the world. This is the incredible journey of that humble colored pencil in your hand. The next time you draw a line, remember that it contains a miracle of chemistry, engineering precision, and a piece of nature. Art is born when it meets this silent technology. Which stage of this journey impressed you the most? Share your thoughts in the comments. If you enjoyed this content, don't forget to subscribe to our channel and click the bell icon to discover other hidden production processes around the world. In the next video, we'll dive into the liquid world of ink pens. See you soon. Scientific and industrial process of color dry pencil production. Colored pencil production is a complex industrial process that combines fundamental materials science, precision chemistry, and advanced manufacturing engineering. This process involves a series of meticulous stages from the preparation of raw materials to the packaging of the final product. 1. double material preparation and formulation. The heart of production is the formulation of the colored paste called pencil core or lead. This paste consists of 4 basic components. Pigments. This is the main source of color. Inorganic pigments, titanium dioxide. White iron oxides. Yellow/red/brown and organic pigments, phthalocyanine. Blue/green, reddish tones are used. Factors such as light fastness, Color intensity and toxicity are rigorously controlled. Binders. These are substances that hold the pigment particles together, giving the pencil strength and shape. The most common binders are waxes paraffin, carnauba, beeswax mixed with various types of evaporating oils, canola, coconut. Carnauba wax provides hardness and high gloss. Fillers. Used to reduce cost and adjust the texture and opacity of the paste. The most common filler is kaolin, a type of clay which whitens and smooths the paste. Additives. May contain special additives such as surfactants, facilitates wetting, antioxidants, extends shelf life, and hardness regulators. These components are needed in precise proportions in massive mixers until a homogeneous paste is obtained. This formula determines the hardness level soft/medium/hard of the pencil. 2. Core lead production, Ekstrüzyonla and Rengin. The prepared paste is fed into an extrusion press. Here, the paste is passed under high pressure through a die with small holes of the desired diameter, for example 3.0 mm or 3.8 mm. Continuous, long colored strips are obtained just like coming out of a pasta machine. These strips are cut into pieces suitable for pencil length, usually 17 to 18 centimeters by automatic cutting machines. These cut raw cores are arranged on drying trays. Drying is one of the most critical stages. The cores are kept in drying chambers or tunnels where temperature and humidity are precisely controlled for 1 to 3 days. During this process, the oils in the binder partially evaporate and the wax crystallizes, gaining its final hardness. Rapid or uneven drying leads to internal stresses and subsequent cracking. 3. Wooden casing production and assembly PENSANDWICH. For the pen body, fragrant cedar or linden wood generally used. These woods are soft, have a straight grain, and are easy to work with. Grooving. The wooden blocks are processed on special machines to create two parallel, semicircular grooves where the pen core fits perfectly. Gluing and closing. A wooden block is placed with the grooves facing upwards. The cores are placed one by one inside the grooves. A second wooden block, also grooved, is then closed on top by applying glue, usually PVA glue. This process creates a giant pen sandwich, or block containing the core in the center. Shaping and cutting. These blocks are passed through molding machines to give the pens their final shape: round, hexagonal, triangular. Then, cutting machines are used to separate each pen individually from the block. These machines first cut the block side by side to the radius of the pencil, and then precisely separate each pencil from the others. 4. Final processing, quality control and packaging, sanding and painting. The cut pencils are sanded with fine-grained sandpaper for a smooth surface. They then enter automated painting lines to acquire the brand's characteristic color. Water-based paints are generally used and applied in several coats and dried. Printing and tip processing. High-speed pad printing machines print the logo, color code, and hardness rating onto the pencil. A metal ferrule ring and eraser are attached to one tip. The other tip is sharpened into a conical shape using automated sharpeners. Quality control. Through random sampling, the pencils are subjected to tests for breaking strength, color intensity, tip brittleness, and wood lead bond quality. Optical sorting and packaging. State-of-the-art optical readers put the pens through a final sorting process based on their color tones, ensuring color matching in the boxes. Automated packaging machines arrange and package the pens in cardboard or metal boxes.